Hello and welcome to today's webinar, Eliminating Network Performance Visibility Gaps. This special webinar event is brought to you by Riverbed and produced by Actual Tech Media. Before we get started, just a little bit of housekeeping information here that you need to be aware of. My name is David Davis from Actual Tech Media, and I'm excited to serve as your moderator for today's webinar. We want this to be an educational event. We want to help you get all of your network visibility challenges solved during this presentation, and so we're here to answer your questions. We encourage you to use the questions box. It's there on the left-hand side of your audience console. I can call your attention to it there. And that's where we'll be answering questions electronically throughout the event. And we'll be doing a dedicated Q&A session at the end of today's presentation. So get your questions in early. Of course, we appreciate all the good morning messages from around the world here and across the United States, but bring us your technical questions as well. We want to help solve your problems. We also have a number of handouts there in the Handouts tab. I can call your attention to that as well. It's there that you'll find the ESG analyst report on the unified approach to complex distributed environments, which talks about the Riverbed unified NPM platform. So I encourage you to check that out. Also check out the solution brief there on the unified NPM platform. And there's a link to the Riverbed YouTube channel with tons of educational videos as well. So great resources there in the handouts tab. You don't want to miss those. And then finally, at the end of today's presentation, we'll be announcing the winner of our Amazon $500 gift card. That will be announced, of course, only on the live event. If you're watching this on demand, I'm sorry, the drawing has already occurred. The prize terms and conditions can be found there in the Handouts tab. And now, before I introduce you to today's expert presenter from Riverbed, I want to first briefly just kind of set the stage for today's topic and talk briefly about why network visibility is so important, in my opinion. Being a former IT manager and network administrator myself, I've seen firsthand, the difference between having full network visibility and not having visibility at all. And having that visibility can prevent that painful finger pointing. I'm sure you've always you remember that time when you were probably called, into the meeting room or the boardroom, and everyone was in there from all the different IT teams to solve some big problem, and there was finger pointing going on. Is it the storage? Is it the application? Is it the database? Is it the network? What's causing this performance issue, this painful slowdown that maybe the end users are having? I've been there before. You've probably been there before. But if you have visibility, if you have real data and complete insight, all of that can be prevented. All of that pain can be prevented, and especially for your end users and ultimately your customers, which is most important for the business. With visibility, you can prevent downtime before it happens. You can rapidly solve performance issues. And most importantly, you can keep your critical applications running and your company making money. If that's the goal of your company, if it's a for-profit company or whatever the goal of the company is, you need to keep those applications running. That's our job in IT or in the networking group, and that visibility is going to be critical. You can also identify and prevent security breaches before they happen, and ultimately save the day. And that's what we in IT want to do. That's our job. It's to keep everything running and to keep the company moving forward. And again, that's why I believe this topic is just so critical. Riverbed has some amazing tools, and this is an awesome opportunity to see a live demo of the Riverbed Unified NPM Platform in action. And with that, I'm excited to introduce you to today's expert presenter. That is Mr. Bill Kuhn, Technical Director at Riverbed. Bill, great to have you on. Take it away.
MPM Technical Director here at Riverbed. In today's webinar, I'll provide some perspective on the value of available sources for network status and performance, with recommendations to help eliminate visibility gaps you may currently have in solving network performance issues. I'll provide an overview of Riverbed's unified NPM platform and close with an illustrated example of unified dashboards into the health and performance of your remote workforce. If you have ever been responsible for the status and performance of a network, you've sat in meetings and said, "It's not the network," more times than you can remember. The network is always the first to blame. Still, after years of becoming faster, more resilient, and a far cry from those early days when networks were commonly the source of an outage or an application performance bottleneck, the first comment from an end user opening a ticket is almost always, "The network is so slow, I can't do my job." So often, the help desk's knee-jerk reaction is to pass that ticket to the network team, who has to prove their network is not guilty of causing the problem. So, how do you prove it's not the network? Better yet, how do you isolate the problem and help application and desktop teams resolve issues as fast as possible? Traditionally, that's been a bag of independent point tools and device-specific views that provide options for a network engineer to go hunt down and find network issues that may or may not be causing the problem. Most of you have probably had more than a dozen network monitoring tools purchased over the last several years. Many of them are actually being used. But by more than just you, is there any integration between these tools for a consolidated view? Regardless, it's rare that a performance problem and its impact can be confirmed and resolved with just one perspective of the network. In reality, the reason you have so many tools is that it almost always takes more than just a single perspective of network health to isolate a user impacting problem. So let's start with a review of 3 of the most critical network-focused telemetry options for monitoring digital performance. SNMP, it was introduced way back in 1988 to provide a software agent with a simple set of operations that allow IP devices to be managed remotely by a network management station, or NMS. The SNMP agent includes management information bases, or MIBs, that store status and statistical information that can be queried by an NMS. SNMP is everywhere in your network. You can leverage these SNMP agents running on all of your network devices for health and performance from the perspective of each device itself. This kind of network status and performance requires SNMP. You won't get visibility into the network devices without it, and that's more than whether a device is up or down. There are common stats that all network devices provide, like throughput, CPU and memory usage. But MIBs are also available with device-specific details related to, for example, firewalls, load balancers, as well as routers and switches. Health and status of the network is critical, but understanding how these devices are configured and connected is vital in most any troubleshooting effort. Collecting network device configuration info is an additional feature typical for an NMS, extending that visibility you get with SNMP by monitoring the configuration of these devices for changes that may impact performance. And with configuration details, real-time network topology and mapping provide visibility into the health of the path of applications as they traverse the network. So even though SNMP has been around for over 30 years and designed to be simple from the start, this real-time status of network infrastructure remains a critical perspective into the health of the network and the applications they support. But is it enough? Does SNMP provide you all that you need to know about the network? You can probably guess that answer, and it's no, it's not enough. SNMP needs help to understand more details into what is using that network. That's where flow technology fits. SNMP was around for 8 years, and then Cisco created Netflow way back in 1996, originally designed as an improvement for their switching technology, where the first packet of a flow was used to find the best route rather than all the packets requiring that overhead. Netflow is simply the ability to collect IP network traffic details as it enters or exits an interface. Many variants have evolved, including the industry standard called IP Flow Information Export, or IPFix. And some versions of Flow Export is almost as ubiquitous as SNMP, available in many network devices, typically routers and layer 3 switches at the least. Flow is an important telemetry for network visibility because it can complement SNMP's perspective of interface utilization with those conversational details into that utilization. Each flow is a record of who is talking to who, when, what protocol and port are they using, and are there DSCP priority tags prioritizing that traffic? And if so, are they correct? And is the traffic routed across the network correctly? This detailed record of every conversation in and out of any flow exporting interface provides the IT teams the details they need to identify bandwidth hogs on one extreme of what's using the network to IP hosts barely using the network, whether it's providing a critical dependency for an application or indicative of a suspicious connection that shouldn't be on the network and certainly not communicating to that server. Having a unified database of all of this network activity promotes discovery and dependency mapping workflows that help identify what needs to be monitored, but also how application components communicate with each other and the end users. Remember, flow is available from many network devices at remote locations, up in the cloud, deep in the data center. It's a cost-effective way to team up with SNMP for a more complete picture into the health of the network infrastructure and details into the network traffic that it is supporting. So now I ask, is SNMP and flow enough? I've talked about SNMP providing network status and performance health of the network devices themselves, and then leveraging those devices for built-in support of exporting flow records, which details those IPs, protocols, and ports running on the network. What about monitoring the performance of the application? If the users are complaining the network is slow, how do you measure that network latency and isolate it from other potential bottlenecks, like from the application servers themselves? That's where the value of packets is supreme, the ultimate source of truth into application performance from a network perspective. Packets are the best source of network telemetry for measuring application performance because there is no better record of network activity than the packets themselves. Because both network and application details are inside a packet, a good analyzer can identify end user and application performance you can't get anywhere else. And it's completely passive, capturing and analyzing a copy of the actual packets themselves with no requirement for any instrumentation on the end user or the application server. One of the primary use cases for packet analysis is to isolate the network performance problem. It can be the answer to that simple question: is it the network or is it the server? And it can save hours trying to prove that it really isn't the network, and instead it's some component of the application. Or when it is the network, using the details available in packets together with that extended reach of flow and SNMP throughout the network and the perspective of network health that they can provide. I'd also emphasize that no matter the automated analysis a packet analyzing tool can produce, having both real-time and historical access to those original packets is critical, not only for identifying issues outside of the metadata automatically created, but for full fidelity of that network activity that security forensics and network engineers depend upon. So why not put packet capture and analyzing probes everywhere? It does more than flow. Why do we need flow? It's really simple. Packet capturing appliances are more expensive technology to implement because you can't leverage the existing infrastructure like you do with flow. You put them where it makes financial sense based on the need, typically in the data center, whether on-premise or in the cloud, monitoring performance of remote end users and the application servers. And that's where the power of bringing flow and packets is realized. That deep dive analysis into application performance combined with the remote perspective of network activity, interface utilization, and those DSCP markings with a unified higher level reporting and forensics analysis of all network activity. Well, let's do a quick review of available NPM telemetry. Network device monitoring, it's a no-brainer. I'd be surprised if anyone listening to this webinar is monitoring a network without an SNMP tool for that red light, green light status of the network. It's been around forever and certainly still the best way to monitor network device health. But what can SNMP tell you about the utilization other than it's high or it's dropping packets? It has no details into who is using the network, what for, and who with. Those conversational details network devices can tell you using flow technology. They just need a way to collect and report on it. This is the most cost-effective way to help optimize bandwidth costs and provide a record of everyone using the network for an extended period of time, but for network performance, and security use cases. So what about performance? How slow is that network? Is congestion actually causing retransmissions? Packet capture and analysis is the best way for a network team to gather details into the performance of the apps. For example, being able to identify whether network congestion, from SNMP, or top talkers from the flow are causing any problems with the end user experience. Packets are that ultimate source of truth for any network team, and at the least should target WAN traffic in and out of where servers support the applications that run the business. Packets help correlate performance details it can provide with the complementary details available from SNMP and Flow. So why all three? And more importantly, why should you consider a unified approach of all three together in a single platform? IT teams are screaming for simplicity and completeness in the network performance to be able to isolate network issues and have no blind spots into that network. The first step is having the available telemetry collected and analyzed. If you don't collect the right data, you've got visibility gaps. And that can leave you blind to the health and performance of both the network and the applications running on it. But just as important is consolidating this data. The combined approach provides a unified view from all three telemetry points, enabling faster identification of root cause and facilitating integrated workflows and insights. And guess what? I just described the strategy behind Riverbed's unified MPM platform. To be effective in managing all aspects of the digital network experience, you've got to have those business-centric cross-domain intelligence across the entire hybrid network infrastructure. Now, Riverbed's unified MPM platform provides better network visibility and faster network troubleshooting by providing the data you need where you need it. Our modular approach can take advantage of the available network telemetry I've been talking about. We leverage SNMP to monitor the network infrastructure health. We collect configuration files to understand the network topology and how these network devices connect to each other. We also collect flow information from the entire network for complete visibility into what's using the network in the cloud, in the data center, and out at remote locations. And we provide real-time and historical access to application performance details and the original packets with an integrated appliance that does both, whether that's inside your data center, out at critical sites, or up in the cloud. And we tie it all together with a unified interface with scalability to support the largest networks tailored to the needs of different groups where everyone is working off a common high-definition data set to help eliminate visibility gaps in this increasingly complex infrastructure that supports the business. Riverbed captures SNMP from all your network devices to give a complete picture of how the infrastructure is impacting the performance of your network and applications. Most network outages are caused by people and process issues, and without accurate on-demand network diagrams and reliable configuration change monitoring, you're in the dark when it comes to better managing a complex network infrastructure. Riverbed automatically discovers your network elements, highlighting new and modified devices and configuration changes, and creates dynamic on-demand network diagrams. And we also provide synthetic testing so you can proactively test various network access points, devices, and apps for availability and performance for consistent, reliable data that helps ensure SLAs. Riverbed also provides a broad integrated view across the hybrid enterprise by combining visibility from the existing network infrastructure using Flow and augment that with performance details by analyzing packet data. This is the visibility you need at the detail and scale to support your network. The ability to discover and map both the network infrastructure and the applications that are using them is a key requirement for today's network teams. Identifying network paths, the priority assigned to mission-critical traffic, profiling behavior for dynamic alerting, provide an integrated view into your network traffic, wherever that may be. And security teams can leverage the visibility for proactive threat detection and cyber hunting. This enterprise-wide visibility into network conversations with the performance details from packets allows network operations engineers a better understanding of app performance and how the network is delivering them. Now, Riverbed, of course, analyzes application performance for every application, every user, from a network perspective using packets. This includes transaction details of every application with detailed application analysis into web, database, VoIP and video, even mapping Citrix user performance to those proxy backend connections for every user. It pinpoints mission-critical application problems quickly, identifying where and when bottlenecks occur so that you can troubleshoot problems faster. And in the same footprint, we also provide continuous high-speed packet capture with second-by-second, real-time, and historical on-demand analytics. Whether problems happened a few days ago, a few hours ago, or happening right now, visibility into app performance is available. Network packets are the single source of truth to identify and isolate these network issues impacting end users and app performance. With a combination of automated historical application analytics, second-by-second views into network traffic as it is happening, and continuous packet capture for when that stuff is hitting the fan and you've got to dive deep, Riverbed provides access to the answers you need with the details to solve the problem. I wanted to show you an example of a unified view into performance that helps illustrate how you can eliminate network visibility gaps. What you are looking at is a complete picture on the health of the network and the impact it is having, specifically on the remote users working from home. This dashboard could also represent users in the office at remote locations throughout an enterprise. In this example, we are leveraging visibility into the health and performance of the remote workforce from all three available network data sources. SNMP polling shows status and performance of each network device as remote traffic enters and exits the data center. In this example, my infrastructure monitoring tool is showing it's all green. There aren't any network issues that SNMP is aware of. Flow analysis provides top talkers with DSCP prioritization markings, not only for this circuit, but visibility into any circuit across the entire enterprise. This would help identify reasons for congestion. Or in this example, maybe it's the Zoom traffic was exceptionally high and not tagged with a higher priority than other social sharing applications like YouTube and Facebook. And the deep automated packet analysis is happening on the network segments between each device. For example, before and after a load balancer to help isolate a network issue. In this case, on the WAN side of the load balancer is where we start to see performance issues. And those top panels show status on the number of users, failed connections, retransmissions, network latency, as well as throughput. So you can appreciate that without this unified approach that leverages more than just SNMP, you would assume the network is healthy and not the cause of any performance bottlenecks. The devices are all green, yet the users are still complaining. By drilling into the red and yellow alerts, you uncover issues like those failed connections or incorrect DSCP priorities for a mission-critical app, and ultimately identify those failed connections as issues on the configuration of the load balancer. But now you have a single dashboard that isolates the problem and that problem domain, whether that problem is visible with SNMP, flow, or packet analysis. And this dashboard is just one example of our biggest differentiator here at Riverbed, that of a unified platform that uses high definition data from multiple points in the network. Riverbed is more than just flow analysis or packet capture or just infrastructure monitoring. We do all three, and we bring it together so that you don't have to do it yourself. I'm going to take a few seconds to walk you through a live demo. In this case, we're looking at that dashboard through our unified platform. And just to give you an idea of some of the things that we can do from here, just think about it, is that we've got potentially data from SNMP polling, flow data from the flow technology, as well as one or more, typically more, multiple packet capturing appliances, all available and feeding data potentially to dashboards that you see like this one. Now you can do a global search by using the search dialog right here in the top right to be able to type on it, for an interface that maybe you're polling with SNMP, or for a location where you're seeing flow information like DSCP tags and top talkers, Or maybe it's an application, the performance of that application. Just type the app name and it'll figure out what data it's got from any available data source and display information appropriately. Now, other ways to look at this information is through the dashboards. We've got a bunch of dashboards templates that basically prompt you for information like the name of the application or the name of the location and those types of things. And based on available data is able to populate those dashboards with relevant information for troubleshooting that particular workflow. In this case, I'm going to call your attention to specific dashboards we call inspectors. I mean, it just doesn't get easier than this. If I click on dashboards, you'll see on the right of this menu drop down various performance inspectors. You know, for example, the interface perspective. If you're troubleshooting a specific interface, it's very easy, even if you didn't have a predefined dashboard for it, is to just open the inspector and then type in some sort of keyword that identifies your particular interface that you're looking for. And it'll figure out which data source has information about that interface. And it could be more than one. In this demo, it's just our SNMP infrastructure management piece, but it certainly does have detail for this interface. So I'm going to open up a dashboard, which I can control what time period I'm looking at here and see various metrics that are available from that SNMP perspective. And don't forget, you can always drill down into more details, even into the actual data source's user interface for full-featured functions. Now, another dashboard that I'd like to bring up is the host group inspector. In this case, I'm troubleshooting our database servers, and I just want to be able to identify what's going on with them. And so I've got a group defined that is associated with those database servers. And if I select this particular database, I can click next, and it's going to go out and figure out where we've seen that. And in this case, we've got one packet capturing appliance. And as I hit finish, it's going to populate a dashboard that's going to look different now because it's based on IP addresses. So much different than something that you would look at from an interface perspective using SNMP. And again, you can right click and see all sorts of different things, including our response time composition chart. You know, different metrics that we're collecting for every IP address that you feed our particular appliances, even down to specific packets. If you're interested in the packets, you can drill from this screen essentially down into the packet captures that we're capturing individually on these appliances. So again, just a really neat way of doing, getting to the information that you want as easily as possible. Now, one other piece that I wanted to show you before I pop out of the demo again is specifically this ability to be more proactive with the tool. You know, in this case, we're setting policies. You see some of these out-of-box policies for our particular packet capturing a probe we call app response. You know, things like database availability, slow server response time for any application, those types of things. What I'm going to go is create two new ones just to illustrate the different types that we've got. In this case, I'm going to create an alarm, and let's just do it on, you know, web application. You know, maybe it's any web app. And we've got two different comparison types. Static means that I just want to trigger it based on a static threshold. We've also got adaptive. I'll show you next what that can do. In this case, I'm going to leave it static, and just to give you an idea, I can come in here and select a specific web app, or maybe it's all apps. In this case, I'm going to leave it to all the web apps, and then set a trigger. Here's where we can add multiple metric comparisons, and these comparisons, these metrics can be, you know, chosen from a list of our specific to web application analytics. So you can see a lot of the response codes for web apps, those types of things. There's page response time, sizes, all sorts of good information here. In this case, I'm really just interested in maybe the number of 500 errors, those server errors. If I ever see them get above, maybe it's, you know, for the yellow, orange, and red alerts, maybe it's 1, 2, and 3 500 errors for any particular app. and I've got to see that at least one time. Maybe I don't need to check every minute, but it has to happen at least one time in a 10-minute period. Select the business hours if you want, and then notification is essentially being able to say, hey, let me send this alert rather than you sitting there watching the dashboard. And those types of alerts can be anything like an SNMP trap, a syslog message, a ServiceNow event or an incident, those types of things, as well as an email. So just an idea to get the tool to leverage available policies to, instead of being reactive all the time, take a proactive approach. And then let's try an adaptive alert this time. Maybe it's on those DB2 servers again, right? I want to go in and set up an adaptive alert. Now, what is that different from a static alert I'm about to show you? So in this case, it's a group of database servers that I've already defined. And the trigger now is going to be on a specific metric. And I'm really interested in if the database ever has a peak or an anomaly in active connections. Typically, they should be pretty consistent. So I want to know, no matter what that number may be for number of active connections, is it statistically different than what we normally see. You know, that machine learning coming into play by profiling behavior over time for this particular metric on these particular servers. And as you can see, there's a lot of different TCP analytics in this particular example to be able to essentially proactively monitor any application on your network. So let's select active connections. And now I've got this ability to, instead of setting static thresholds, to set deviation factors. I'm going to actually have the system, because it's been up for a while now, look at the last 12 hours and tell me what those deviation factors should be to not trigger at least any alerts as we compare 30-minute windows back in time over the last course of the day. In this case, it's drawing out this river graph, which is essentially showing you our tolerance level, where in the gray line in the center, you can see the number of active connections that were actually happening as they're bouncing around throughout the course of 12 hours. And then based on the math applied to this machine learning, we're able to associate tolerance levels in the yellow, orange, and then outside of that would be the critical or red alerts. And, you know, for any particular 30-minute window in this case. And so I could also say, well, yeah, you know, I don't want to be, I want to see some alerts, you know, I want to tighten up my deviation factors so I can change this and get a little more or less tolerant. Now you can see that we would have a host of alerts coming over the course of 12 hours based on these deviation factors. Again, a way of very finely tuning some automated processing of analytics to proactively alert on deviant or anomalous traffic. Again, same notification capabilities as our static alerts. So that's certainly something that I wanted to show you, that we do, you know, some out of the box, but also able to fully customize it to look for particular conditions that you want to know about that are happening on your network. So let's just finish up. The last thing that I wanted to talk about is something really outside of MPM. It's all about what Riverbed can do for you, and the fact that now that you've got some visibility into the performance of these users and their applications that they're accessing, and troubleshooting capabilities to identify and isolate problems on the network, well, what can you do about it, right? So now that you know that there's a problem with performance, you got to have some sort of way of improving that. And if there is no way, it's just a speed of light issue, or there's nothing that you have control of, like with a SaaS application, and they're going directly to that cloud from wherever they're at home or at a remote location, you know, you've got to take advantage of available instrumentation. You know, today's workforce is more mobile than ever. And there's a huge increase in users now working from their home. And there's never been a better time to implement acceleration on the client themselves. So no matter where they are, no matter what applications they're using, no matter what the network, they'll have the best experience possible with a combination of app acceleration and visibility into the performance of those applications, even including those SaaS applications like Office 365, Salesforce, and Teams, with new applications being added all the time. So I hope you have a better appreciation of the value of SNMP, flow technology like Netflow and IPFix, and packet capture and analysis, and the benefits of what each of those can provide. But more importantly, how those perspectives of network performance are best when brought together in a unified platform with a unified view that helps eliminate visibility gaps and promotes collaboration. Thank you.
All right, excellent presentation. Thank you so much, Bill. Really do appreciate that. I've just brought up a poll question for everyone out there in the audience. The question says, what additional information would you like about the Riverbed solution? And we'll just leave that up while we answer some of these really good questions that have been coming in from everyone out there in the audience. Thank you for the questions, by the way. And if you have some, just keep them coming, and we'll be doing our best here to answer as many of them as we have time for. So, Bill, you ready for some Q&A?
I sure am.
Excellent. All right. So let's see. First question I want to ask you here. This one comes from David. He's asking, are there privacy implications with packet capture?
Yeah, there certainly can be, and it's just really just depends on the particular situation for that your security folks have for compliance. Being able to see into potentially encrypted data, because we are able, with the appropriate keys, able to unencrypt, specific web traffic, for example, and actually analyze it at a web level. But one of the things that we have done from the get-go is provide that flexibility of when you are capturing this information to be able to either not capture it at all and still analyze it, or capture it in its original encrypted format where you wouldn't be able to see any sensitive data. And even inside specific web applications that we're analyzing, where you could potentially see things like credit card numbers and those types of things as you're analyzing that payload, being able to mask that data so the users of our system wouldn't be able to see any of that information that's private for a particular individual. So the idea behind this, excuse me, though, is that we can analyze data at least the ability that the packets are able to provide to us in the case of packet analysis, and then choose whether to save those packets or not, as well as, even if we do save them, slice those packets. And then for our larger appliance, we'll even encrypt that at rest so that you don't have to worry about it. Even though those packets have sensitive information, we're encrypting them through our technology to basically say if somebody gets access to those packets on those hard drives, it's encrypted anyway. But thanks.
Very
That's
nice.
a good question. Mm-hmm.
Excellent. Yeah. Okay. Yeah. Thank you for explaining that. I find that very interesting as well. Another question here. I'm sure you probably heard this before. Do you have any kind of comparison between Riverbed and some of the other alternatives out there? This question comes from Daniel.
Sure, Daniel. Yeah, it's a common question. There's a ton of tools out there, especially when you get into that infrastructure monitoring. Been around forever, like I said, practically forever. But the idea is that there's tons of tools out there. So how do you differentiate? And every tool is going to have a bell or whistle, at least in my opinion, that some other tool may not have, including us. Right? We may have a bell and whistle someone else doesn't have, and vice versa. So, the sort of the moral of my story today was really to identify what I think is a competitive differentiator is when you're considering tools that focus on specific functionality, make sure you understand their telemetry options and how they bring that together to help eliminate those visibility gaps. Now, on our website, I think you've got links to that as well. We've got some competitive information for various competitors that is available, at least at a high level, but I'd encourage all of you that have any sort of questions on how we may compare with something that you own now or something that you're comparing and thinking about, certainly contact your Riverbed sales team, and we'd be happy to sort of walk with you through why we think we stand above these other MPM competitors. Thank you.
Excellent. Yeah. All right. Next question is from Steven. He's asking, does Riverbed monitor my entire network, on-premises endpoint all the way to cloud servers or web pages? That's one part. The second part is this hardware or software?
Yeah, it just depends, right, on the instrumentation. But that's a good question. Lots of good detail in there that I'll spend a minute here. But certainly, monitoring your entire network, our strength is really the scalability and the fact that we capture everything. We don't do. I mean, obviously, as data gets older, you start to top it just for extending the history, but um, for most workflows, it's all based on every single packet that you can feed us, every single flow, detailed polling, configuration file information, and the history of that, those types of things. And we're designed to scale. And these can be virtual or physical appliances, depending on your choice, as well as in the cloud. A lot of it just depends on capacity requirements, but also where you're wanting to instrument packet capture, for example. Do you want to run our software up in the cloud? It can certainly do that. Do you want to have these big, packet capturing appliances that can store up to 2 petabytes of storage? That's more, in line with a purpose-built appliance that has the RAID, has the IOPS and those types of things to handle that type of volume. So it's a combination, and we'd certainly love to talk to you about the different options based on your particular environment. But we can put that up in Amazon, up in Azure. We can, for example, you can have that sort of at least some visibility from Amazon directly through VPC flow logs, as well as leverage our appliance up there to give both packet and flow visibility. And if we are seeing the packets, we can get into those web analytics. And I noticed that you specifically asked about web pages. That's something that I think differentiates ourselves from other web analyzers in that we actually stitch together different web objects that make up each individual user's page request. So you can get that detail into how slow a particular page is responding for a more accurate representation of end user response time. But it is all about where you can instrument. And so as long as we can instrument, we can get that visibility that I've been talking about. Thank you.
Excellent. All right. Thanks for helping us to understand the architecture there, how that works. Another question here. Tim is asking, does Riverbed have any customers that are healthcare organizations?
Absolutely. Yeah, I guess the easy answer is yes. But a lot of them are using us to basically monitor their entire environment, whether it's Citrix-based, whether it's monitoring individual hospitals, doctors' offices. We're designed basically to handle that type of environment and provide them the details. Not just from a network performance perspective, but I've been involved where we're monitoring sort of those devices that the healthcare owner can't do anything with. They can't load any software on it, those types of things. And so basically monitoring the perimeter around that, being able to proactively identify suspicious activity to and from those very critical devices where lives depend upon it. So certainly we spread across multiple different industries, but healthcare is one of our stronger ones.
Excellent. Excellent. All right. Lots of good questions in the queue. If you see any that you want to, answer, let me know. I'm just going to keep running down some of the other questions I have here. This one, they're asking, they say, my network is really big. Can Riverbed scale to 500, 1,000 interfaces and analyze flow and packets from 500 plus locations? How scalable is this?
Yeah, good question. Because that is something I hoped I had emphasized through the presentation, because it is one of our strengths, is being able to handle any network from very small to very large and priced appropriately, right? So the idea is to be able to fit into your particular needs, and a network of that size. A lot of it all depends, but we've got single instances of SNMP polling that can support more than 500,000 interfaces by scaling horizontally using a container and microservices based approach. Being able to analyze flows. And it's not just, when you ask the capacity issue, it's not just what can you handle, because everybody can handle a lot, right? It's what you can do with that data. How long do you keep it, and those types of things. So it's the combination of, saving every packet, every flow, information from every device, and being able to scale to the size that networks are these days. And it's certainly, I think we do both very well.
Excellent. And then what about scaling down to smaller companies or smaller networks? Would this make sense for them as well?
It would, sure, yeah. So it's all, you know, different models, different licensing SKUs, those types of things to fit, anything from very small networks. I can say some people would start, if you wanted to get started with something in Riverbed, sort of in anticipation of evolving into this unified MPM approach. It's as simple as putting even a virtual or a small physical appliance in your data center that's able to monitor the traffic going in and out of all of your locations, or to, in and out of those VPN circuits, just basically to give you a good idea of who's going in and out of those circuits, but also associating that network delay versus server delay, as well as other details into the performance of that. And that's something very easy for those small customers to get to started with, but also big customers is start small and then spread that visibility as needs permit.
Got it. Okay. And then I know we talked about, preventing finger pointing, and I like this question. They're asking, what applications can Riverbed help um, actually isolate whether or not it's the network or the server? Basically, can it identify where the performance bottleneck is?
Yeah, it can certainly. That's a really good question. If you guys think about that slide that I had with the the typical use case for packet capture is isolating that network and server delay to sort of say, hey, network looks good, congestion isn't a problem, but they're still complaining the network is slow. Well, it's like, well, wait a minute, we need that answer, and that's what it does, and we call that a response time composition chart, which basically has the overall end user response time at the top of that chart with the details of all the different types of components, that three-way handshake that starts with every TCP connection, those types of things, retransmission delay, and just different pieces of performance that impact the overall end user experience. And we do that actually for every TCP based application. So basically everything other than real-time apps like VoIP and video, we can analyze it at TCP level because the TCP, has the detail in those packets to do that. Just like we can do with Wireshark, right? We're the corporate sponsor for Wireshark and certainly work with it very well. But the idea is automate a lot of that capability. And that's what our packet capturing probe is doing. And so it's able to do that on any TCP. And then we can step it up into the payload and into specific application analysis to do similarly response time composition charts for like web activity. Now we're talking, instead of network and server delay, it's more about page response time and how the network and server affects that. And so very specific. VoIP and video, is typically UDP based, doesn't have those TCP stuff, but we can analyze and decode that protocol to basically associate mean opinion scores, the jitter and RTP packet loss and those types of things. So it's any application essentially. We record data as much as we can for any protocol and then leverage the particular protocols like TCP, the higher level application traffic like web, database, VoIP, those types of things to provide as much detail as we can out of that packet automatically, with still having that ability to go to the original packets for even a deeper dive that we can do with by saving those packets.
Got it. Okay. And then this is kind of a long question. They say, I'm interested in getting network performance detail, but we're not in a position at this time to replace our SNMP or flow tool. Can I install your packet capture and analytics features without having to purchase the flow and SNMP pieces?
Yeah, in a perfect world, everybody would be needing all three of these pieces, but that just doesn't really, at least from a Riverbed perspective, but that just doesn't happen very often. It's certainly common that someone's got something that they either know and love or just invested in, so there's no way that they're going to replace it. And so the idea is that each of these modules that I talk about, that leverage the SNMP, the flow, and the packets, each of them can operate individually and be best of breed, essentially, where, we've been in every NPM and Magic Quadrant from Gartner, for the 7 years that it existed. And if you look at their marketing guide, essentially our strategy is what they're describing is to integrate this kind of capability. So the idea is that, though, if you want to say, hey, we just really want to put that one, packet analysis probe in our data center and at least get an idea of what it can provide, and then maybe down the road think about integrating SNMP or Flow, those types of things. That's always an option. Pick and choose the module that makes sense for you now, with the sort of the awareness that could plug into an overall, unified MPM strategy moving forward.
Excellent. Excellent. All right. Well, I think we're running out of time here in our live Q&A session for this event. I want to respect everyone's time. Bill, it's been really great having you on. Excellent demo. Thank you so much.
Oh, you're welcome. And thank you, everyone, for your attention today.
And thank you to Riverbed for supporting today's event. Don't forget about the handouts tab there. It's there that you'll find links to the ESG analyst report on the unified approach to complex distributed environments, and also the solution brief to the unified NPM platform that you just saw Bill demo here a moment ago on the event. So make sure that you check that out. And also, I want to encourage everyone to watch for a follow-up email from Riverbed. It'll have tons of resources in it, including links to training, trials, and much more. So keep a lookout for that email from Riverbed. And before we wrap up, I want to thank everyone for joining. We, of course, always appreciate your support. And I want to announce finally the winner of our Amazon $500 gift card. That's going to Shelby Huddleston from Kansas. Congratulations, Shelby Huddleston from Kansas. We'll reach out to you to deliver that prize. Thank you, everyone, for joining today's webinar on eliminating network performance visibility gaps, brought to you in partnership with Riverbed. I hope that you learned a lot and have a great day. We'll see you next time. Bye-bye.